Okay, good morning everybody. Welcome to another question on Form 4 Chapter 5 Waves. So let's have a look at this question. If you want to get the PDF version of this question, you can just head to the description box down below. So diagram 1 shows the interference pattern of water waves produced by two coherent sources S1 and S2 in a ripple tank. Okay, so you can see here there are actually two different waves. Okay, so if I draw this out for you, this is one of the waves like this. Okay, coming from S1, and this is another wave like this coming from S2. Okay, now these two waves, right, they will basically interact, or they will basically overlap with each other. And when the waves overlap with each other, right, this is a situation called interference. Okay, now what actually happens when they overlap, when they interfere with each other? You basically need to add the waves together to find out what is the result, okay, of these two. So for example, if one of the wave is going up and the amplitude of the wave is, let's say, 2, another wave is also going up at the same time, and then the amplitude is also 2. When these two parts, they interact, they overlap with each other, they will add up together, and then they will form a big wave which has an amplitude of 4, right? So same thing, if one of the wave is going down, amplitude is -2, another wave is also going down, amplitude -2, they will add up together and create a big wave going down, which has an amplitude of -4. Okay? Now, if one of the wave goes up with an amplitude of +2, and another wave goes down with an amplitude of -2, then when they overlap, when they interfere, you add up together, +2 plus 2 minus 2, you get 0. Okay, the waves will end up cancelling out each other. Okay, so the whole idea about interference means you add up waves together. Now, there's a word for that. When you add up waves together, the word is called superposition. So they ask you, what is interference? You say interference is the superposition of two or more waves. Okay, the superposition of two or more waves, meaning you are adding the waves up together. Now, if you want to add on to this answer, right? Okay, you can say both waves must come from a coherent source. Yeah, the key part is the first part. You add up the waves together. If you want to add on, you say both waves must come from a coherent source. Okay, which brings us to the next question lah. Okay, it asks us, what is the definition of a coherent source, right? So coherent source basically means that these two sources, they must be exactly the same. Yeah, so exactly the same can mean a lot of things lah, but in terms of wave, right, when you have two waves that are exactly the same, these two waves, they have the same frequency, or they have the same wavelength. Okay, so you can see, let's say I said this wave and this wave look different. Because why? Because their frequency or their wavelength is different. Okay, yeah, so you say sources, or you can say waves that have the same frequency. Now, you don't need to write frequency and wavelength, because frequency and wavelength, these two things, right, they will affect each other. If you have a high frequency, you have a low wavelength. You have a low frequency, you must have a high wavelength. Okay, so either one, you just have to say have the same frequency, or you can say have the same wavelength. No need to say both, right? Okay, now it's not just enough to have same frequency only, because, right, let me give you an example. If I draw this wave out and I just copy and paste the exact same thing, then these two waves must be same frequency, same wavelength, correct or not? Okay, because I copy and paste ma. But if one of the wave come out a bit slower, right? So for example, when you play a song using two speakers, yeah, you and your friend play together, but your friend his phone lag a little bit. Then when he play, the music is a bit slower. Then you will hear it differently, correct or not? The effect will be different. Yeah, you will hear a very, very weird noise like overlapping. So this is the same thing also. If you want to get a very nice interference pattern, you cannot have a lag wave. Okay, so you must say these two waves, right? They must be in the same step. They must have the same timing. Okay, so the proper word for this is they have the same phase. Yeah, and are in phase, or you can say and have the same phase, right? So this is the meaning lah. Okay, they must have the same timing. Okay, the next question. Draw and label an antinode line and a nodal line. Okay, so before we draw, you need to know what is an antinode and what is a node first. Okay, so if you look at node, I like to remember like this. Node means no more, nothing, nothing there, nope, nothing there already. So just like I mentioned, right, if you have one wave going up and another wave going down, when they interfere, they will cancel each other out. So that becomes a node, nothing left there. Okay, so you can see from this graph, they tell you the thick line is the crest, which means up. The thin line is a trough, which means down. Okay, so you got to find which area, right, the thick and the thin line, they intersect with each other. Okay, that's where they cancel each other out. So I can see from here, right, look at this point, one thick and one thin. Okay, or you can see this point here, also thick and thin. Yeah, this point here, this point here, and this point here. These are all nodes. Okay, and when you connect all these dots together in a line, you will get a nodal line. Okay, which is a line that connects all the nodes together. Yeah, you can find another one here as well. This one, node, node, node. Here also node, right? Actually, this is also a node lah. So you can connect them and you can get another nodal line as well lah. Okay, now antinode means the anti of this lah. Antinode means the opposite of node. So it's where you get the up and up together to get big up, the down and down together to get big down. Okay, so you're gonna find the points where the two thick lines they intersect with each other, like this part, or two thin lines they intersect with each other, like here. Okay, yeah, here as well. All right, and then you can say here, here, right? So again, you see, if you connect these lines, yeah, they form a straight line, you will get an antinodal line. The points are called antinodes, okay? But the line is called antinodal line. Now, of course, the center is also usually always an antinodal line as well. Like this. Okay? Antinodal line. Alright? So that is how you solve this wave question lah. Okay? If you learn anything, remember to like and subscribe, and you can write in the comments below which topic you would like me to do more questions on. Okay? See you next time. Bye-bye.